Hi, did you know that in this entire world, we have 10.63 million kilometer cubes of fresh water, and in that, 30.1% is groundwater, from which we get 50% of drinking water for this entire world. Groundwater faces a lot of issues, but today we are going to talk about this one. Hi, my name is fluoride. Don't miss the negative charge on me because that makes me different from the zero charge chemical element which is fluorine. I occur naturally in rocks and water. You humans need me, but not too much. If my concentration in your drinking water goes above 1.5 milligrams per liter, you have to suffer from dental fluorosis and skeletal fluorosis. And if my concentration in your drinking water goes below 0.6 milligram per liter, again you have to suffer from tooth decay and also hinders your bone and enamel development. While working in an area which is groundwater contaminated with fluoride, I went and searched for research papers and articles that will open up the doors of fluoride and how it enters our groundwater and what can we do about it. Let me tell you the story of that journey. This story takes place in two different locations. First is below the surface. Here we have huge, massive solid structures known as rocks. Rocks are present below the soil, below the oceans. Consider your houses to be rocks. Then whatever your houses are built of or whatever you have inside your house are minerals. Our protagonist of this story, fluoride, is a mineral. In between these rocks slowly moves our groundwater, and the part taken by groundwater is known as aquifer. With time, these huge massive rocks break down into smaller particles because of extreme weather, rainfall and biological activities of organisms. Now when our groundwater moves over these rocks, they carry these small particles along with them. Also, when our groundwater is in contact with the rock, there are a lot of interactions going between the characters in the groundwater and those in the rock. The first character is calcium. The calcium bonds with fluoride to form fluoride that is found in rocks. When this fluoride in rocks meets the carbonate ion in water, the calcium and carbonate ion both like each other and want to make a new friendship bond. But for that, calcium first breaks bond with a fluoride ion and then makes bonds with our carbonate ion, resulting in the fluoride ion in rocks becoming free and entering into water. Another character has the name aluminium, and it forms a very tight complex bond with fluoride in the rocks. Now when this meets hydroxide ion in water, and fluoride being the smart one and also having the same size as the hydroxide ion replaces itself, resulting in the hydroxide ion forming the bond with aluminium in the rocks and the fluoride ion getting free and entering the water. Another character that will enter now is H plus ion. More the concentration of H plus ion in water, we see the water is more acidic. The fluoride in rocks loves to make new bonds with H plus ion. So higher the concentration of H plus ion in water, more is the amount of fluoride in rocks that will enter into water. Now we move into the second location of the story, and that is above the surface. When a volcano erupts, it releases the hot melted rocks from below the ground along with ash particles and a lot of gases including hydrogen fluoride. Our industrial activities also release fluoride into the atmosphere through aluminium manufacturing, phosphate fertilizer manufacturing and a lot more. So in the atmosphere we have fluorides as gases and also as small solid particles. With time, some of these particles may settle down on the surface or on the vegetation. Others may be brought down during the rainfall and join the surface water or groundwater. So that's the journey of a protagonist fluoride into groundwater. Hope you enjoyed it and will join us soon to hear the story of our next journey of finding ways to manage it.